So let's dive into our panel. My pleasure to welcome our speakers here and then hand over. First of all, Kunal Chandra, he's the Director for Strategy and Sustainability at RWE. Kunal, warm welcome here on stage with us. Then we have Andreas Klesse. He's the CTO of E.ON Energy Infrastructure Solutions. Andreas, your applause, warm welcome on stage. One is Katharina Peterwerth. Katharina, she's the Vice President Business Strategy for Grid Technologies at Siemens Energy. Katharina, warm welcome. I would say last but not least, this is Michael Freiherr. He's CTO Global of Güntner. Michael, also your applause, warm welcome. And then last but not least, well, I'll hand over to Susanne, who will moderate this session. So, Susanne,
thank you.
Stage is all yours.
Great. Well, nice to see you in this session here. We are a bit competitive. Who gets the most guests? So nice seeing you all of here in our energy session with my Elefantenrunde, as I would call it, right? We have very exciting people sitting here. You know, in politics, when you call this the Elefantenrunde, these are the most important ones. It's not because of the size of the body or anything like that, right? It's the importance they carry with them. Energy. The energy transformation, I have to cite someone from the panel, and maybe it's a little question for you to find out who said this in our preparatory talks. In the past, renewable energy infrastructure was deemed sustainable by design. Right. Then let's take a quick look at the report by the International Energy Agency. A scenario that meets the Paris goals in that scenario shows clean energy technology's share of total demand rises significantly over the next 2 decades, over 40% for copper and rare earth elements, 60 to 70% for nickel and cobalt, and almost 90% for lithium. So don't get me wrong, the decarbonization of our energy sector is paramount importance of meeting these Paris Agreement goals. On the other hand, we should not get lost in the carbon tunnel vision. We need to look at the material side of this energy transformation, of the mobility transformation, and that's what we want to discuss here today, right? To see that this energy transformation is secure and sustainable at the same time. So, just as a quick warm-up, one sentence, I did this before. Katharina, do you want to get started? In one sentence, why is circularity essential for you as Siemens Energy?
Well, what most people don't know, for every euro we invest in renewables, we invest another euro in grid infrastructure. And actually, grid infrastructure is a lot of material. It's steel, it's copper, it's aluminium, and we want to contribute to a sustainable transformation. We're going to contribute to a better world, actually. So circularity for us is most important because we don't want to be the bad guys in the energy revolution. We want to be part of that really nice and good journey, making this a more sustainable world. And this is why circularity is most important, because we can't do without the materials, but we need to make sure we bring them into a circle.
Absolutely. Andreas, your thoughts?
Yeah, so I'm Andreas, so I'm dedicated for, and also the E.ON Energy Infrastructure Solutions team is driving the energy transitions in cities and industries. And this is on 3 columns. So it's about energy efficiency, integration of renewables, and also sector coupling. We are quite well in integrating renewables, but energy efficiency and reusing thermodynamically not right, energy more than once, and using waste energy for other purposes. So this is something what is driving us and really a game changer in cities and industries.
Yeah, thank you. We'll get at that point as well. Kunal, RWE's perspective, circularity.
Well, I think it's part of the promise of renewable energy. If you call something renewable, that by definition means it takes nothing from the planet. And that was the quote. And so for us at RWE, the renewable energy transition basically has three elements to it. One is decarbonization, which everybody's focused on, and I very much like our discussion on carbon tunnel vision. Not to say that it's not important, but let it not overshadow all the other challenges that are necessary for the transition. The second one then, of course, is circularity, because it should be renewable in scope 3 as well, not just in the energy, but also in the material that it uses. And going one step further, not for this panel here, but for us is also important, a net positive biodiversity, because in some way that's talking about not taking away from the planet in terms of the biodiversity and the species. So for us, and for anyone in the industry, it should be part of the promise that if you transition to renewable, you do it on all 3 dimensions.
That was more than one sentence, but it's been building up. Michael, let's get into the round already. I think you're going to answer this. Why is it important for you in the same way as I want to ask the first question? Because you actually have set yourselves a really ambitious goal. You want to develop fully circular products, and by that you're going to tell us why it's important for you as Güntner.
For us at Güntner is circularity, and especially why we set that goal. It's important for our future success, but not only that. More importantly, it's about the quality of life and maintain the quality of life, not literally for everybody in that room, but literally for everybody on Earth. And that's why, because we are in several applications, I think we will come to that later on in the panel discussions then as well.
Okay. So, when you've set yourself this target of making cooling systems fully circular, what is required to make this commercially viable for you? What are your challenges there?
I think first is modularity. Modularity is something, so we are very fortunate because we always think in modules for decades right now. It's our heat exchanger core, it's one of them. Then we need an air movement device, let's say, there's fans attached to our units, and then we just make a nice chamber for that, so to assembly everything. So we are already thinking in modules, and then probably of some of the units we put some electronics in. So the modularity is not a big thing. On the other hand, I would say our engineers are really experts in thinking about how do I optimize the assembly, but probably not the disassembly of our units. And this is something we are working on right now to find it out, because once we are able to get the first units back, we need to have that solved. Another thing is recyclable materials. Instead of going for materials which are really a nightmare when it comes to recyclability, and don't get me wrong, recyclability for me is really the last frontier. So first of all, we want to reduce and reuse and all that stuff, but if you use the wrong materials in the first place, you will never end up with that. So we are basically using materials like aluminum, copper, and steel, which is the biggest portion of the materials we use, and I think this is a pretty good foundation to come up with the first circular product in our industry.
Yeah. Mentioning these materials, Katharina, copper, steel, this is what you need. What does circularity mean for Siemens Energy in that respect, from the material side, but maybe also in terms of new business models?
Maybe I pick one of our products. So what we do is basically switchgears and transformers. And if I pick one of the transformers, just to give you a little bit of an impression, when we are talking our large power transformers, this is a thing that's 500, 800 tons. It's like 15 times 5 times 5 meters. So that's huge. It contains roughly 50, 60 tons of copper, another 120 of steel just in the core, actually. So this is huge amounts of material we are talking. On the other hand, our products are out in the market for like 40 years and longer, so we have great customers and they really use our stuff for a very, very long period. However, we also see our supply chains, and if we are looking especially for copper, for examples, we see that if you want to produce in 10, 20, 30 years from now, we might have troubles to get the copper in the quality we need that. And this is why we're now thinking how we can actually get back the stuff, because our customers today basically recycle in many cases. We look into refurbishment, of course, but also the question is, are we the ones to get it back, to get the material back into our new transformers and make it much more circular? The product is actually designed for easy dismantling, which makes it a lot easier. Transformers have been manufactured for decades, basically in the same way, and it's quite easy to dismantle them. So you get the steel, you get the copper, and a couple of other things. And yeah, this is why it's important for us. But in the end, it should be a business model, and that's the big question. How can we actually make it a business model? Because what we also see, customers will not pay that green premium that they might have been paying in the past. So it becomes increasingly difficult, especially on a global scale, to make it a business model, but we're working on that.
Yeah, absolutely. Kunal, you also mentioned this, so if, like, you're planning multi-billion euro investments in energy generation infrastructure. You're trying to integrate circular thinking and principles. Where is this most feasible today? And feel free to cite some examples as well.
Yeah, well, I think the advantage that we have is that we have a lot of scale at the point of use. So if you look at one of our solar farms, we build the large ones, 100, 200 megawatts. So you're talking about a large quantity of material. So that sort of already solves a bit of the reverse logistics, because you start with scale compared to in a retail business where you have to have a point sort of collection for the reverse logistics. And then, so that sort of gives some advantage. A lot of this stuff is not coming off of its operational life cycle. If anything, this will stay in the ground for quite some time. But we are still already starting to look for opportunities where right from the beginning, we could use material that is recycled. For example, green steel. We worked with Siemens to build our wind turbine towers using green steel, which immediately reduces our scope 3 emission. Because technically, if you use renewable electricity to recycle steel, you are coming at zero emissions from the beginning. That's what we have done. That's where the opportunity is. And there is a particular example which I like is with the wind turbine blades that we have. So because the linear economy was always optimized for a certain outcome in the past, somebody, and very intelligent engineers, came up with these adhesives which would make sure that these wind turbines, when they are spinning at high speeds over a very, very long period of time, the wind blades don't come off of the pitch, right? So they sort of stay together. But that meant using chemical adhesives, etc., which is hard to break down ultimately. And therefore, you can't, just by design, you can't recycle something like this. You destroy it to the point where it's no longer valuable. So what we've done now for our German wind farm in Kaskasi, again with Siemens, use the blades that are sort of recyclable. Mm-hmm. So already starting to make sure that we design for circularity, or at least don't deliberately put obstacles to circularity in the design.
Yeah. So, and this is, I really like this. I have to point this out. You know, we have the technology provider, we have the energy generator, and now let's go to the distribution networks of E.ON. We have really all the important actors here, active in pushing this energy transformation forward. Andreas, your point of view on what's circularity? Or respond to Kunal if you wish.
I like what you said, because you said you're working with Siemens because they are producing or helping you the green steam, but actually also in the long end, we are partnering up with steel manufacturers to produce green steel. So it's really, circularity is a common thing, and it's about partnerships, about collaboration. It's not that somebody can do this alone. And this is, I think, why it's also not so easy, but it's important in the new way of working and the new way of how the world is working, that we form a partnership, strong partnerships on regional basis.
Yeah. Partnerships is one point. I mean, you said this word of energy or waste heat, which is something that's very important that you are working on with E.ON. Yeah. We know in a circular economy there should not be waste. We have the material side, but we have the energy itself as well. Do you want to tell us a little bit more why we can't treat energy as, or waste heat is a term that we should not have in the future anymore as well?
So for me and also in a transformation for cities and industries, waste heat is one of the most important topics. So you have on the one hand side a lot, and you know this, a lot of waste heat in industrial processes, what you can reuse with your neighbors in reusing the heat, in also with a, let's say, low efficiency producing more electricity. However, there are much more sources coming into cities. So when we talk about data centers, several hundreds of megawatt producing data, but also in the same way producing waste heat that is very often being unused, but actually you can heat a complete city with this. So reusing the energy that we use for other purposes and using it in a circle And perhaps one last thing, when you think about, let's say, the climate change today, where you always see this distributed and central cooling system for residential houses. Also, this waste heat there can be reused for heating or taking a warm shower in it. So there's a lot of opportunities, and we are not missing the energy, we are missing the reusing of it.
Yeah. And Michael, when we talked before, I mean, you were mentioning this huge untapped potential that we have, or that you are seeing yourself as well.
Yeah. That's for sure. I mean, when we talk about the potential in terms of physical potential where waste heat is available, I think that is already mapped. You can look it up in the internet. So TLK Energy did a very good exercise of mapping all the heat sources up, at least in Germany. So we know there is waste heat available. Then as an engineer and from a technology point of view, I would say technology is also not, everything is there. We just need to use it. And you currently just mentioned it, data centers is probably one of the biggest polluters of waste heat. But then what I understand from all the discussions I have with all the players and stakeholders is that it's really difficult to find a counterpart for a data center, because you cannot just build a thermal next to a data center, so you can have somebody who can actually use that amount of waste heat. And for city operators, for example, they really need to have a very reliable provider of a certain amount of heat over, 10 to 20 years. While the data center operators, they need to change their CPUs within a time frame of, 18 to 24 months. So this is probably not a fit. But now, coming back to the question of the potentials, I think where it actually works is where you have smaller boundary conditions with less stakeholders in the game. Look, for example, so now I'm driving a lot with my fully electric car, by the way, BMW. And I really like that. So now, once I'm at the charging station, I always wonder, I've never met a gas station for a very long time. I don't know if they even exist. But if we come up with a concept like we have charging stations and also provide some food and drink, like at the old gas stations. What I always have in mind is, because I don't know if you considered that or you saw it, and you realize that the charging station itself is also a heat rejector. Mm-hmm. And as an operator of such a station, let's say, it would be my certain interest to get that waste heat inside my store, so I'm completely independent during wintertime and from heat. And this is something what we did with one of our customers. So they are the largest food retailer in Europe, and they have a certain interest of actually doing that within their food retail stores. And this is what we came up with a solution for them, and we've also talked about partnerships already. That's crucial. We really need to partner up very closely so our engineers can actually understand the needs and the application from them, and they can understand what the solutions provided by us actually means for them, as you correctly said, as a business case. And now, at the end of the day, and for a long time right now, they are really happy because we are really independent. We are managing all the energy streams in their food retail shop, and it works. So technology is there, just get it done.
Yeah, the technologies are there, and that gets me to the point. The technology is there, the technological fixes, but the competitive edge, Katharina, is so important, right? So what kind of signals from customers or regulators would make circularity a more viable business proposition for you? Is there something that you really want to emphasize here?
Regulators is a very difficult question for us because we have a very global footprint in terms of production. We are a true global firm, and we basically serve a lot of countries across the globe. So regulation for us always means we would need to look into 20, 30, 40 different countries. And if we do have a North America cluster, then we have in Europe different countries, but then we also do Middle East, we do Asia Pacific, several countries. So a regulation just in Germany will not help us, actually. Mm-hmm. So this is why we are rather looking into real business models and to ask ourselves, how can we make this a business model, how can we also maybe share profits between us and customers or between us and suppliers to make sure we can do that independent of regulation? Because driving regulation on a global scale is actually not feasible, just impossible. And that for us depends then very much on how raw material prices are going to develop over time. Also, how our customers look into that. And to be honest, that's very much driven by the region they are in. We just had a very interesting discussion in Australia around sustainability, and they say, well, electricity prices need to be low, transmission prices need to be low, because energy is something that everybody should have. We want to be sustainable, and they invest a lot in sustainable and renewable energies. However, they are not there to really invest into a more sustainable grid, because they prioritize the right to have cheap energy higher, and they call it the social license. So there's different views across the globe, and we need to manage those. So really making sure we share profits, we make sure we find the business model, that's actually crucial for us. Because we can't expect our customers around the globe to pay for it, but it's rather really depending on raw material prices, on how this develops actually over time.
Yeah. That sort of links a little bit, Kunal, to what you said, circular front runners don't really get rewarded in tenders. So what needs to change? I mean, what is your perspective also from the international level?
Yeah, I think the first thing to note is that when you are in a commodity industry like we are, at the end of the day, we have to operate at scale, and you produce a commodity. So the end product itself is not very differentiated. For example, if you are recycling small things like fabrics or clothes, you can find a small group of buyers who have the willingness to pay for the additional costs. But when you're talking about completely redoing the energy system, ultimately cost will be the main driver. And cost comes from two things. One is the inherent cost of development, whatever, and then the regulations. And so in Germany, for example, a couple of years ago, before we had the war in Ukraine, there was a very clear signal from the government that they would be awarding renewable projects also based on what we call NPC, the non-price criteria, which would include then how much circularity you have, how much biodiversity you have. And of course, when those kind of announcements came out, we were motivated to do Kaskazi recycling blades that I just described. But at some point, voluntary sort of sustainability is no longer affordable, because it would make us so uncompetitive that ultimately RWE sustainable plants will not get built. So I might have the best design on paper, but if it doesn't get built, and I think that's a real challenge. At the same time, it's not something we don't understand, because the energy trilemma, as we describe it, consists of affordability, availability, and acceptability. And in this sort of paradigm, availability of energy is the most important thing, what people call security of supply. And when it's about security of supply, we will pay any price, like we have seen in 2022. Power prices went up totally crazy, up to $900 per megawatt hour. But of course, once we have supply, then affordability becomes important, because if you don't deal with that, then you have a rampant inflation in the economy, and then suddenly all the other challenges which will not allow you, or which would sort of overtake all the other considerations. And then, of course, lastly comes acceptability. And that, again, is partly dependent on the regulations. What does regulation deem acceptable? So it's not about making excuses that we can't do. Of course, we can demonstrate to the government what can be done, but ultimately to scale it up, you need the frameworks.
Yeah. So I'm jumping a question, but it links well, Andreas, to what you said something when we talked, and I like this a lot. You said, the uncertainty has it's gotten so much bigger. Looking 10 years back, it was pretty clear what you had to do as a company. Now it sometimes seems to be changing on a daily scale, right? So how do you make decisions despite this ever-changing landscape politically, also on different fronts? So what does that mean for E.ON?
Yeah, so I'm personally pretty sure the certainty will never come back. Yeah, so we are. So when you look in what is happening with digitization, and speed is getting faster every day. Yeah, so to get security for the next 20 years is something what I think will not come back. However, that doesn't mean that you should do nothing and wait. But what I feel, and I think what is our purpose always, and how our approach is, it's not about the one big thing that you need to do. So about the one big thing for circularity, the one big thing to get to net zero. So it's about small steps, getting on the journey and acting. And always be a little bit better every day and progressing, and then you come to the point where you're always competitive and always at the edge. So it's not about the one decision anymore that you need to take. The only one decision you need to take is starting the journey with somebody and with a partner, and rely on getting into the direction.
Yeah. Michael, that brings me back to you, starting the journey. I mean, rising copper prices was something that got you going, but now you're exactly sort of taking these steps. How does that work, and how do your customers react to that? That would be interesting.
Yeah, as I said, copper is one of our main materials, and copper prices are always concerning me. And you're right, we are close to $10,000 per ton, which is more than doubled over the last 10 years. But what scares me most is the availability of copper. And let me frame that a little bit for all of you. So we are producing heat exchangers for all the sectors and in many applications, starting from just making sure that you have a signal on your phone, cooling down the data centers, taking care that you can have a fresh shower in the morning, because our units are also used in water treatment plants. Then we are in almost every food application, not in only cooling down beverages or all the other final products of the food, but also within food processing. Like instant coffee probably also needs to go through our technologies. This sector alone represents 17% of electricity consumption globally. Also air conditioning and refrigeration. In countries like the United Emirates or in Dubai and specifically, it's 71%. This sector alone is about to grow 3 times the size until 2050. And we need to take measures to be energy efficient and all. For that, we need copper. Then we have all the other sectors, and we have the same goals for decarbonization. We are also selling into those sectors. And what concerns me really is the availability of copper. So the copper consumption globally is rising and rising every year a little bit more. So, and it's expected to be 30 million tons within the next 5 years, coming from 20 million tons just some years later or before. There is a very good chance, while we are sitting here and talking, that this year we will overconsume the availability of copper globally. So the copper extraction and availability will be 23.3 million tons, and we actually need, for all the products in our sectors, we need to have 23.7. Don't get me wrong, there is no scarcity of copper, but just the production availability or the production what you can have as an output is limited right now, and it's expected for the copper mining industry to cope with that demand. They need to invest $2 trillion. And this is something, I'm in simple mind, but for me it's a lot of money, and I'm not sure if that is working out. So my point is just the following. If we are not starting right now to invest resources into circular economy and get the copper back, and we can reuse it, it's not only harming our business, our sector, it's actually harming the quality of life of every single one of you sitting in that audience and many millions of people living everywhere in the world. That's the statement.
You made your point. Katharina, how does this resonate with you? How do we get going to, I mean, we've been talking about numbers before. What happens when you hear these numbers? These might sound familiar to you, and how do we get going quickly? How do we overcome the barriers that we are currently facing, which we've been discussing before?
I mean, the numbers are familiar because we have those large numbers in our products, and actually one of the challenges for us is that currently, I would even say, again, picking the transformers, we have a closed loop. Because what our customers do is first of all, we refurbish a lot for them, and then they recycle. So the question for us is not only the copper itself, the question for us is also the quality of the copper, because we need a super high quality. And then the question is, how can we actually organize, as you said, in partnerships, so that our customers are willing to give the transformers back to somebody that can recycle the copper in a way that we can use it again in our products. And that's the current challenge at the moment. And there we need to partner. We need to work together. It's nothing that we can solve, because we are not going to go into a transformer as a service model for a 40 years lifetime. Actually, that's not feasible for us, also from a balance sheet perspective. So it's rather really talking about what can we do, how can we become better in refurbishing, so then we don't need to recycle in the first step. How can we push it out also with digital solutions? So asset digitization is a huge topic for us, making sure that we have a long lifetime and we even enlarge the lifetimes, but also making sure that we can from time to time overload our equipment, which means we need to put less into the grid, which might also be helpful. Just the size, we're going to double the size of our company within the next 3 or 4 years, and then making sure we get it back. Yeah. That's how we get started, actually. Building those partnerships with copper producers, making sure it always comes into a circle we like and not the one it's in today.
Yeah. We've been talking, well, we are in the discussion about barriers, obviously, what's holding us back. Maybe turn the perspective towards policy. Can policy push us forward in terms of circularity, making circular materials more competitive? I just want to quickly touch on this point. A quota, so make it compulsory to use the recycled content. Kunal, what are you as the RWE thinking about aspects like this?
I think policy is one thing, and like what we've seen in decarbonization, you need some early policy signals that would activate the entrepreneurs, right? And ultimately, I still believe that if you want to make a change that we are talking about, the scale, the fundamental input is the ingenuity of people. And we saw it in renewables when we got early subsidies, then suddenly there were entrepreneurs activated on the cost of photovoltaic panels, etc., sort of went down. I still believe there's a lot of work to be done on a technology front on circularity, simply because if you look at the supply chains that we have running in one direction, they already have a huge carbon footprint. Now, if you run them all the way back, so whatever you get from China, now you send it back to China for recycle, just imagine you just double, first of all, the CO2 footprint. So you create a scope 3 problem on circularity. So what would eventually have to happen is that somehow the recycling, etc., will have to be more decentral. And how do you do things which are decentral and profitable? Well, the answer is, for example, in 3D printing. So you need digital technologies, robotics, whatever, to be able to do these things at smaller scale, but still economically feasible. So I think the regulations have to work on two sides. One is, of course, to penalize in case we are not pricing these things properly in, but also to recognize that a fair bit of technology will need to be innovated, and I think the group in this room, it's much more relevant what signals they pick to then say, I'm going to put my time and energy on this problem.
Cool, okay. So as we're nearing towards the end, you're going to get this final question from me. What are you going to do over the next 12 months to push circularity and scale it? So Kunal, let's start with you.
Well, I'm definitely, first of all, we are going to look at the big ticket items, which we understand. But as Andreas pointed out, we are very much looking for partners right now, knowing fully well that this is not a problem where someone has a ready solution. But even if you want to be ready in 20 years, we got to get started today and seriously.
Yeah. So everybody heard that. There's potential partners sitting in this room. Michael, what is it for you? What are you going to do to scale?
Same for us. We are definitely following up on the projects in collaboration with guys like you, but with with other industry players. And what we also already did, we received and we reached out to some of our customer base. And what we are basically doing is working on acceptance of all of that. I mean, it's just to understand what they want to have. We need to work on, as I said, the acceptance. So it's in question if the reused or remanufactured unit has the same quality and the same performance, let's say. This is now what we want to prove. And then from that we can work on. But I'm I'm not worried that the technology wouldn't be there. So from a technology point of view, we have that. For me, it's more working on the psychology aspects of circularity.
Okay, interesting. Andreas?
Not easy for the next 12 months. So, of course, what we're doing...
Okay, I'll allow you 24.
No, of course, we are engaging with regulators to get things going. But anyhow, we need to do it and shout out what is possible. Because a lot of good things and ideas and opportunities stop because people don't just look on the individual topic and problem and not seeing the complete system. So it's about talking to each other and communication. This is the most important thing there.
Cool, thank you. Katharina, final words for you.
For us, we are in a phase of enormous growth. We're going to double the size of the company. There's so much to do. So people put their attention on putting out new factories, on AI, optimizing manufacturing, whatever we do. And I, for myself, will make sure that we have enough time also focusing on those rather long-term topics, making sure we stay competitive in a very long future, not only focus on the next 5 years.
Thank you. Perfect. I'm looking towards the moderators. Are we allowed questions?
If you pay for it, yes.
Is there anybody who wants to start engaging? Do you have some questions? Go ahead. There's a microphone for you.
Thank you. Hi, so I'm a doctoral candidate at the Technical
If you
University.
put a bit closer, it's difficult for us to hear at the moment.
Closer or further?
No.
Okay. Oh. I'm a doctoral candidate, and I'm wondering, you mentioned collaborations quite often. However, startups usually tend to get bought out, and then they become a part of the bureaucratical machine that lives within many big companies. And what are you doing to counter that?
To whom is this? Everyone? Who are you asking this question?
In general, everyone mentioned collaborations.
Anybody feels inspired to answer?
So, of course, we are looking into startups and into investing into startups. And what we try to avoid is to say that they get integrated the corporate machine and they lose their spirit. So it's from us about getting minimum stakes into it and supporting the startups to grow with our business and being integrated into our projects. So our project is the base to growth, and this is how we believe that we can help and support.
Any other questions? Front row is active, really good.
Jörg Hefer. So a question to all of you. We have a coupling of the gas prices to the energy prices.
In Germany, yes.
In Germany.
In Germany.
If we would decouple this in Germany, what would be the downside? What would be the upside? And could this accelerate the competition in order to get faster in regards to CO2 emissions, but also development for newer technology?
I can give it a shot. I mean, just we have thought about this. I think the question is you have to think about an alternative. So what will be because the reason why it is coupled right now, because gas is the marginal producer, most expensive. So of course, when gas sets the price for everything else is set. The alternative would then be the cost plus model, where you reimburse every developer for the cost that they incur, and then sort of give them a reasonable profit. It has its pros and cons, because then it's a highly regulated kind of a generation business, and government will have to then see how do they maintain transparency and all of those things. So, I mean, there are good sides and bad sides. The bad side is, the good side is if you have a war in Russia, power prices will not go through the roof for every electron. Downside, of course, is that there is less innovation, less risk-taking ability in companies like us, if they know that everything is going to be fully regulated.
Okay.
We are not in the upstream business anymore. So
well, anymore, yes.
not anymore. So I give it to the colleague here.
Any other questions? If not, then I really would like to thank you very much. discussing the material side of the energy transformation. It's been great having you here. Thanks so much, and thank you.
Thank you.